Now that we've seen that the derivative of sine of x is cosine of x, the derivative of cosine of x is negative sine of x, that's going to give us the tools to figure out the derivatives of the other 4 standard trig functions. So let's do that now. Let's start out with the derivative of tangent. So let's look at y equals tangent of x, and we want to figure out what's the derivative of this function. And in order to do that, my strategy here is to just rewrite tangent as sine over cosine, and then I'm taking the derivative of that entire expression. And to do this, what I want to use, I think the most natural thing for us to use here is going to be the quotient rule, because we've got a quotient of 2 functions. My f is sine and my g is cosine. And we're just going to plug in that quotient rule and find the answer. And just to remind you, if you've got a quotient of 2 functions, the derivative is f prime times g minus f g prime divided by g squared. So here our f is sine of x, our g is cosine of x. So let's plug all that in. And I'm going to get derivative of sine, that's my f prime, that's cosine of x, times g, that's cosine of x, minus f, that's sine of x, times g prime, that's derivative of cosine, that's minus sine of x. And I'm dividing everything by cosine squared of x. This notation means cosine of x squared. It's function cosine of x, quantity squared. And so let's just reduce this algebra a little bit. This cosine x times cosine x, that's cosine squared x. And then the 2 negative signs give me a positive. So I get cosine squared x plus sine squared x, all divided by cosine squared of x. And what I want to do here is use my trig identity that for any x, cosine squared plus sine squared equals 1. So this is nothing but 1 over cosine squared of x. And so that's secant squared of x. So this is telling you that the derivative of tangent is equal to secant squared of x. I want to do one more for you. Let's look at the derivative of cotangent of x. So cotangent is going to be cosine over sine of x. And we'll just apply the quotient rule again. So plugging in, I'm going to get derivative of cosine is minus sine times g, that's sine of x. That's my f prime times g. I'm going to subtract f times g prime, so that's going to be cosine of x times the derivative of sine of x, that's cosine. Everything divided by g squared, so that's sine squared of x. And now I want to reduce this a little bit. So how can I do that? So in this case, I've got a negative sign, then I've got sine squared, and then I've got a negative sign that I'm going to distribute out. So give me negative sine squared plus cosine squared. I'm dividing it all by sine squared of x, trying to get out of the way there a little bit. And so once again, my trig identity tells me sine squared plus cosine squared equals 1, and so I'm left with minus 1 over sine squared. And that's going to give me, well, what this is, remember that 1 over cosine is secant of x. So 1 over cosine squared, that's secant squared. 1 over sine is cosecant of x. So 1 over sine squared is cosecant squared. So you get negative cosecant squared of x. So this tells you, when you put it all together, that the derivative of cotangent of x is equal to minus cosecant of x. And there's a nice relationship between these, or cosecant squared of x, of course. And there's a nice relationship between these two derivatives. Derivative of tangent gave us secant. To get the derivative of the cofunction, cotangent, all I had to do was switch secant to cosecant and put in a negative sign. So now we've got derivative formulas for 4 of the standard trig functions: cosine, sine, tangent, and cotangent. All that's left are the 2 others. We ask ourselves, what's the derivative of secant and cosecant? And that, I challenge you to derive those. So what you're going to do is you're going to write, for instance, if you want to find the derivative of cosecant, write out 1 over sine of x, and then use the quotient rule, like I've done here, just plugging in, and do any simplification you need, then you'll quickly find the formulas.